So anything you say can and will be recorded. Do what? You like that? Oh, someone in the class. Someone actually joined already. And if you want to join, you can. I will be posting this link on eClass later, so you can go. It'll be a YouTube link, and you can go watch the parts of it. The trick is I won't have chapter subtitles and stuff like that in these videos like I had in the other videos, but at least they'll be recorded. So our unit circle. If you look in the back of your pre-calculus textbook, you have this kind of thick page in the back. You'll have a unit circle picture back here. This is what you're going to use. I am actually going to be giving this unit circle to you. You don't have to memorize this unit circle for the test. You're going to have that unit circle. You, however, are responsible for all the other formulas on this page as we're using them. But I will be giving you the unit circle. This is the unit circle on the back cover of the book right there. Notice that the points here, like this is 1, 0. You look up at the top on the y-axis, it's 0, 1. Then this is minus 1, 0. And this is 0, minus 1. That is the points on our circle. So each of these are x, comma, y. Each of these points on the circle are x, comma, y. And we call it a unit circle because the radius is 1 on this. So just think each of these points are x, comma, y all the way around. So what is a point for pi over 4? What is x equal to at pi over 4? Square root 2 over 2. And what is y equal to at pi over 4? Square root 2 over 2. Now, suppose it was at pi over 6. What is x equal to? Square root 3 over 2. And y is equal to? 1/2. You're reading those off of that. That's just the x and y value for those angles, where those angles intersect the unit circle. That's the circle of radius 1. Notice that this also gives it to you in degrees. So they've done the conversions from the radians to the degrees on there. So you can do the same thing. If you're looking at 120 degrees, you know this is the x value and that's the y value for 120 degrees. You're going to have several homework problems that are going to ask you what is the x value and what is the y value for the angle, and they'll give it to you either in degrees or in radians. Simply look it up on your unit circle. They don't want it in decimals, they want it in the values off of the unit circle. So look it up on your unit circle. Those are the easy problems, and you have several of them that are easy. Okay, the equation for the unit circle is x squared plus y squared equals to 1. Because of that 1 right there, it's called the unit circle. Unit is equal to 1. That's our definition. Because this is the unit circle, because r equals to 1, when you plug it in for your arc length formula, you have s is equal to 1 times theta, which means the arc length is equal to the degrees. That's the only circle that happens for. That is not of great importance. You don't have to memorize that fact. Here's what you do need to know. Our trig functions, the sine function, sine of the angle, this is the angle. Sine of the angle is equal to the y value. Cosine of the angle is equal to the x value. Tangent of the angle is y over x. Cosecant is 1 over y when y is not equal to 0. Secant is 1 over x when x is not equal to 0, and cotangent is x over y. So notice the relationship between cosecant and sine. They're 1 over. So you really only have to memorize the first 3. Secant is going to match up with cosine, and so secant the angle is going to be 1 over cosine of the angle. And then cotangent matches up with tangent. Cotangent of the angle is equal to 1 over tangent of the angle. So that's the relationship. You really only have to memorize the first three. The others are just going to flip them upside down. You just have to know which ones they go with. So when you're trying to memorize which ones they go with, remember that they can't start with the same letter. They have to start with different letters. So cosine would have to go with the secant because they can't both start with C. They have to start with the different letters. That's the way I remember. There's actually a different reason for that. The co in front of it actually tells you it's the function that goes with it, and they, yeah, co and then sine, or co and then, yeah, that's what it goes with. But it's not consistent all the way through. This one is consistent. Okay, keep these in your mind. We're going to be using them. Evaluate the 6 trigonometric functions at each real number at t equals to pi over 6. So I guess I'll put 1 right here. We're going to have sine of pi over 6. Do you guys have your pre-calculus, your textbook with the angles at the back of it? No? Okay, let me see if I can go back. So what are the numbers at pi over 6? Square root 3 over 2 and 1/2. So let's go forward. So at pi over 6, I'm going to write that first of all. We have square root 3 over 2 and 1/2. That's the x and that's the y. So sine of pi over 6 is equal to y. Let me write this down. Sine t is equal to y. Cosine t is equal to x. Tangent t is equal to y over x. And then cosecant t, I can't spell today. Cosecant t is equal to 1 over y. Secant t is equal to 1 over x. And cotangent t is equal to x over y. So what would sine of pi over 6 be equal to then? 1/2. What is cosine pi over 6? Square root 3 over 2. And what is tangent pi over 6? Well, 1/2 square root 3 over 2. What do you do when you have a fraction in the denominator? Yeah, flip it upside down and multiply by it. So it's going to be 1 over the square root of 3. If you want to multiply it by its reciprocal, that would make it then square root of 3 over 3. But you don't have to do that. I think WebAssign will accept it just like that. I don't know, I haven't tried it in this one. I'm perfectly happy with 1 over the square root of 3. Okay, so that's tangent. Then we have cosecant. Cosecant of pi over 6 is 1 over y. So it's 1 over 1/2, which is 2. Secant pi over 6 is 1 over x. 1 over square root 3 over 2. So that's 2 over the square root of 3. And then cotangent pi over 6 is, I'm going to go to that one right there and flip it upside down. Cotangent is x over y, but you can go and use your 1 over the tangent. Oh, I won't take shortcuts. You guys are looking at me blankly. It's x over y. Square root 3 over 2 divided by 1/2, which just ends up being a square root of 3. Yeah, you'll get the same thing by flipping 1 over the square root of 3 upside down. Okay, so that's number 1. Let's do number 2. We're looking at 5 pi over 6. Here's 5 pi over 6, so what is the x value? Negative square root 3 over 2, and the y is 1/2. So negative square root 3 over 2, 1/2. And let's run through them. Sine of 5 pi over 6, 1 over 1/2, which is 2. Cosine 5 pi over 6 is 1 over x, so it's 1 over, sorry, I'm doing cosecants. I'm already, maybe I walk out the door and come back in again. 5 pi over 6, this is just the y, it's 1/2. This is just the x, minus square root 3 over 2. I was doing secant and cosecant. Not yet. Soon. Tangent of 5 pi over 6, y over x, so it's 1/2, minus square root 3 over 2, so it's 1/2 times minus 2 over the square root of 3, so minus 1 over the square root of 3. And then your cosecant 5 pi over 6 is 1 over y, which is 2. Secant 5 pi over 6 is 1 over x. So that's going to be negative square root 3 over 2. And cotangent 5 pi over 6 is x over y minus square root 3 over 2 divided by 1/2. So it's minus a square root of 3. Okay, so some of these can be negative, some of them can be positive. Now, what happens when the angle is negative? Let's go back to that unit circle. About now you should be going, no, she didn't tell me anything about negative angles. Where are the negative angles? There aren't any on the circle. Does this mean we can skip the problem? Yeah. Negative pi over 3 is the same as 5 pi over 3. Remember those coterminal angles that we calculated? That's why we did them, so you can read your unit circle. Negative pi over 3, that would be going clockwise, and amount of pi over 3 ends at 5 pi over 3. So for negative pi over 3, what is the x value? Where are we? 1/2, and what's the y value? Negative square root 3 over 2. Yes. So we have 1/2 negative square root 3 over 2. So let's start. Sine of negative pi over 3. What is the y value? Negative root 3 over 2. Cosine of negative pi over 3. What is the x value? 1/2. Tangent negative pi over 3. It's y over x, so it's negative square root 3 over 2 divided by 1/2, which is a negative root 3, right? And then cosecant. So this is going to be 1 over y. So it's 1 over negative root 3 over 2, which is equal to negative 2 over root 3. Do what? Oh, we're good? Okay. Secant minus pi over 3 is going to be 1 over x, and x is 1/2, so that's 2. And then what's tangent to minus pi over 3? Yeah. Flip tangent upside down. That works. Okay, you guys have a practice problem. Question? Yeah, they are, because they are off by 180 degrees. Secant for number 2 is, oh no, this is a 5 pi over 6. This is a pi over 3. Oh.
Shouldn't that be 1 over, or negative 1 over square root of 3?
Negative 2 over the square root of 3, like that. Yeah, you're right. I didn't flip it, did I? I've been making mistakes today. Good call. Okay, get your papers out to try that.
If you get 1 over 0, that's
undefined.
0 also is.
Yes, 1 over 0 equals undefined. So let me go back to our unit circle. And your problem was using t equals to pi. So there's the unit circle. So you'll want to write down your -1 and 0. Does everybody have that part written down, the -1 and 0? Practice problem, yeah, you will want to do this one. And then we'll go and I'll advance the screen to the definitions. What you're using t equals to pi, which is going to be your point right there. And then you have to plug in for the 6 functions. You want me to go forward one more screen? To the circle? Yeah, this circle is very useful. Do what? No, What is it?
Start with the blank sheet of paper with a circle on it. The other two parts, then we have to do everything on there.
Oh my. That's incredibly fast. That's a lot to write down there in a short amount of time. Okay, there's your formulas, guys. Hey, did we get that finished? So, what is sine of pi, guys? 0, what's cosine of pi?
1.
-1.
Exactly what I was.
Yeah, that's exactly what you meant. And tangent of pi. Cosecant, undefined. Secant, -1. Cotangent, undefined. So when they're on the unit axes, x, y axis there, you're going to have some of them that are undefined. Usually 2 of them are undefined on that. Okay, so that was our practice problem. The second part of this chapter is discussing the domain and period of sine and cosine. From pre-calculus, what's the definition of the domain? It's everything that the x values can be, right? Everything that the x can be. Now, when you were in pre-calculus, I told you that you have to check for fractions. Do you have division? You're looking for division of 0 or the square root of negative numbers. Now, sine and cosine do not have square roots in them. You could write them with fractions, but they only have numbers in their denominator. So that means that the domain for sine and cosine is all real numbers. Domain for sine and cosine is all real numbers. The range for sine and cosine is a set -1 to 1. You saw in the unit circle that it took values. The biggest values were 1. The smallest values were -1. It didn't go beyond that because on the unit circle, it went from -1 to 1 in both axes. And sine and cosine are defined based off of the values on the unit circle. So the range is -1 to 1. Now here is where things get a little strange. Periodic. No one's really told you a definition for periodic. Periodic means it repeats itself in the same increment. So every 2 pi, the sine function goes all the way back around again. So you could add 2 pi and get the same value. That's the period because it repeats itself every 2 pi. Same thing for cosine. It repeats itself every 2 pi. So the period for sine and cosine is going to be 2 pi. That's where it repeats itself. We use that to find the coterminal angles. That's why we were adding and subtracting 2 pi, because that was the period for the function. You add and subtract that to find your coterminal angles. That's what's happening there. Now, one other topic that we're going to tie these all together. A function is even when f of minus x equals f of x. In other words, the minus sign goes away. It's not in the second part right there. Even functions, if you think about an x squared term, minus x squared is equal to x squared. That's why we consider it even, because the exponent is even. So this is a behavior when your function has an even exponent. Odd functions is when the minus sign comes out in front. So think about a minus x cubed. That's a minus, and then you have your x cubed there. So it multiplies your original function by a minus, and that behavior happens when you have an odd exponent. Turns out the cosine function is even, the sine function is odd. So cosine and secant, remember secant is 1 over cosine. So if cosine is even, then secant is even. So cosine and secant are even. Sine and cosecant and tangent and cotangent are both odd. Those are going to be odd functions. And when you get into calculus 2, those of you who are going on to calculus 2, some of you will, we're going to actually have a way of writing these as polynomials. You can actually write sine and cosine functions as polynomials. It's a sum of an infinite number of polynomials. But for cosine, all the exponents are even. For sine, all the exponents are odd. So that's what's happening on that. That's why they're even and odd functions. So we're going to use that fact to evaluate these. Evaluate 13 pi over 6. This is going to be using the period. Pi over 6. First of all, let's check and see if 13 pi over 6 is anywhere on our unit circle. We have 11 pi over 6 is the biggest. I don't have a 13 pi over 6. So where is 13 pi over 6? Yeah, it's pi over 6. 13 pi over 6 minus 2 pi leaves you a pi over 6. So 13 pi over 6 is the same thing as pi over 6. We're using our period or cofunctions, whichever way you want to think about it. So we're looking for sine of pi over 6. We should have paid attention to what that was back there. What was, here we go back again. What is sine of pi over 6? It's the y. 1/2, yes. Oh, went too far. So that's going to be 1/2. Now let's think about cosine of minus 7 pi over 2. Let me draw ourselves a unit circle right here. This is 0, this is pi over 2, this is pi, this is 3 pi over 2. Now, it's negative. So which direction is it going? Clockwise. 7 pi over 2. Here is minus pi over 2 is down here. This would be a minus pi. This would be a minus 3 pi over 2. But I need a minus 7 pi over 2. So I have to keep going. This would be a minus 2 pi. This is a minus 5 pi over 2. This is a minus 3 pi. And then this is a minus 7 pi over 2. So I had to go around the circle 1.5 times to get to it. So what angle do I use from the circle? Pi over 2. How could I have gotten that without doing that? I did that a different way. You add your 2 pi to it. So you have minus 7 pi over 2 plus 4 pi over 2. So that's minus 3 pi over 2. But that still doesn't get you the answer. So you're going to add 2 pi to that. And that equals pi over 2. So you keep adding 2 pi until you have a positive angle. Coterminal angles that we did last time. Keep adding 2 pi, or if you're more visual and you like to spin around the circle, then go around the circle, counting until you get there. That's actually my preference. I like to go around the circle. Now plug that in. So this is equal to cosine of pi over 2. But what is cosine of pi over 2? This is the point 0, 1, 0. Okay, that is the first method for doing that. There is a second method for this. You can use either method on your homework, which is why I'm doing both of them. We know cosine is even. So that says cosine of minus 7 pi over 2 should be equal to what? And now you can go around it clockwise. You'll get 0 again. That actually ends up, when you subtract 7 pi over 2 minus 2 pi, take it down, you get 3 pi over 2, and so you get cosine of 3 pi over 2. 3 pi over 2 is 0 minus 1 down there, so that also gives you 0. You can use either method to do it. I really don't care which method you use. Any questions on that? Question?
So the idea that the cosine and secant are even, that's kind of just a shortcut to what you
Yeah. Yeah. And that's exactly what I'm going to use on number 3.
Okay, the secant, all you're going to do for sine, basically.
Yeah, sine is odd. And notice they didn't tell me the angle, so I can't look it up on the table on the circle. We don't know t. So what does that mean? Yeah, sine is odd. That tells you that sine of minus t is equal to minus sine t. So if sine t is 4 over 5, then what is sine of minus t? Plug it in. Yeah. That's not very good. Try that again. So there's our answer for that last one. That last one actually ends up being easier. That's all you're doing. You don't have to go to the unit circle. You just have to recognize what's happening on that. So what if I had my own little problem right here, and I said cosine t is equal to 1 over 10, say. What is cosine of minus t? Cosine's even. Yeah. Yeah. So you have to be careful. Cosine's even, so the minus sign just goes away inside, not outside. Okay? If I had said cosine t is equal to minus 1 over 10, what is cosine of minus t? Yeah, but it's still negative. The sign stays the same for cosine because it's an even function. You change it for sine because it's odd function. Odd means change the sign. Cosine means keep it the same when you're going from that minus t inside. Any questions on that? Okay, I think we have a practice problem. Evaluate cosine of minus pi over 3. Let me draw you that unit circle so we don't have to go all the way around. At pi over 3, Well. And down here, so you can do it either way that you want, 1/2 minus square 3/2. So whichever way you want to do it. So to get that done? Not sure?
Yeah.
Yeah? What's your answer? 1/2. We're done. Make sure you turn in your homework. Write your name on, your quiz points for today. Write your name on your papers before you turn it in. We are done for today. Let me stop that recorder.